Hello and welcome. In this video, we're going to look at a video from Vacuum Wars regarding the filtration performance and filter classes of robot vacuums. In particular, we'll focus on the following statement.
And to be fair, as far as I can tell, most reputable manufacturers of vacuums and air purifiers do spend the money to make actual HEPA filters.
And this statement, especially in relation to the robot vacuums shown and the genuine Roborock filter that was tested, is absolute nonsense. I'll show you now why that is the case. Roborock uses EPA filters of class E11, and contrary to the claim made by Vacuum Wars, this information can actually be found quite easily on their official website.
Roborock themselves makes no claims about their filters on their website or Amazon, despite being actual HEPA filters.
You just need to do a little research, including checking the FAQ section and not only the shop pages, and you can find the specification of the filter's performance. You can see that here in the image. What these specifications actually mean I'll explain next, because it's important to understand that there are different types of testing standards that define these filter classes. As already mentioned, an E11 filter is a filter from the group of EPA filters. The EPA standard is defined in the EN 1822 norm. This is highlighted here in red. This means that an E11 filter must achieve at least 95% separation efficiency for the most penetrating particle size, the MPPS. What exactly the MPPS is, I will explain in a moment. Also highlighted here in yellow is ISO 29463. In simple terms, this is essentially a newer version of the EN 1822 norm. It introduces more finely graded classes regarding separation efficiency. So if we compare the US HEPA standard with filter class E11 from Europe, we can see that the requirements for the HEPA standard are significantly higher. Here, we need to achieve a separation efficiency of at least 99.97% with respect to the most penetrating particle size of 0.3 micron, which is firmly defined in the US standard. I'll come back to that in more detail later. With the E11 filter, however, only a minimum efficiency of 95% must be achieved. And even if we are at the upper end, meaning we reach just under 99.5% efficiency, that still makes a significant difference. Let's assume we have 1 million particles with the US HEPA filter. Only about 300 particles remain unfiltered, whereas with the E11 filter, around 5,000 particles are left over. So, how does the US HEPA standard fit into the European HEPA standard? As defined in EN 1822, which we looked at earlier, the US HEPA standard lies somewhere between an H13 and an H14 filter. That said, there is still a difference regarding the most penetrating particle size, which I'll address in the following. To conclude, however, it should be said that an E11 filter is, as mentioned, still quite far from meeting the US HEPA standard. The following goes for fiber filters what EPA or HEPA filters usually are and is a bit simplified to keep it short. The filter's ability to retain particles depends on physical and mechanical characteristics such as diffusion, interception, impaction, screening effect, and electrostatic effect. A fiber filter's efficiency is depending on all these effects. There is a particle size range between 0.1 to 0.3 micron, where, depending upon the specific filter media, the combination of these effects work worst. Such particles are too big for true diffusion effect, but too lightweight and small to be filtered by impaction, screening, or interception, making filtering them out more difficult. This particle size is called MPPS, most penetrating particle size. High-performance filters such as EPA, HEPA, and ALPA filters have their efficiency stated in this particle range, determining it as the absolute minimum efficiency. So particles bigger and or smaller than MPPS are filtered with higher efficiency rates. By understanding this, you will also understand that common descriptions like filters particles down to 0.3 microns are pretty much misleading, when in fact, as explained, this is the size they capture least efficiently, not the smallest they can filter. Particles smaller than the MPPS are generally captured more effectively through diffusion. The US HEPA standard assumes that the MPPS is always the 0.3 micron size no matter of the given filter media, while the EN 1822 standard tests this in more detail to identify the MPPS of the given filter in the range of 0.1 to 0.3 micron. So, what about other manufacturers regarding filter performance claims? What information do the manufacturers provide? Dream, for example, used to state that the D9 filter and also the L10S Pro filter were of class E11. However, I couldn't find anything about this for their current robots on the Dream website or in the FAQ. If I am wrong here, let me know in the comments. And even in those earlier specifications, what's missing is any kind of external certification. That means you basically either trust this claim, which at best is based on internal testing, or you don't. At iRobot as well, the HEPA requirements are not fulfilled. For the 800 and 900 series, the specification given is 99% at 10 micron. For the S9, it's 99% without any indication of particle size. In that case, the claim is simply about allergens. All of this is rather vague, and for the current series, they've omitted such specifications altogether. On iRobot's website, I couldn't find any further details either. So again, everything is quite vague, lacking any external certification, and far removed from HEPA standards. In the smoke test conducted by rthings.com, which is designed much better than the one from Vacuum Wars, something I'll go into later, you can clearly see a significant difference between the filtration system of the 900 series and that of the S9 series, even though rthings' HEPA statement doesn't really hold up here, which, as mentioned, I'll discuss in more detail later. UFI does not provide filtration performance data for most devices either, as can be seen here for the S1 Pro. Instead, they refer to high-performance filters, as is also mentioned in the FAQ. It is also stated there that no HEPA filters are used, but rather so-called high-performance filters. For the E20, however, a filtration performance is actually specified. It states a filtration efficiency of 99.97% for particles as small as 0.3 micron. On paper, this corresponds to HEPA filtration performance. However, if you take a closer look at the asterisk, it refers to internal tests, along with the additional note that actual results may vary depending on the living environment. So there is no external certification, and this limiting remark should also be viewed with caution in the overall context. Ecovacs also does not meet the HEPA standard. And with Ecovacs, things get pretty wild, or actually even a bit misleading in my opinion. On the product pages for the filters and also for the robots themselves, there are no specifications at all regarding filter performance. However, there is a very detailed blog on the topic of HEPA filtration. And yes, that's where it really gets strange. Because on the one hand, the blog does a good job of explaining why HEPA filtration is important, what it is, and even mentions the relevant testing standards. But then, as the text goes on, it casually states that, well, actually you don't really need HEPA at all. Multi-stage filter systems, like the ones used in Ecovacs robots, are supposedly sufficient. And the reason for this is that the current product lines, namely the X8 and X9, only use an M6 filter, while the current T50 series use an F9 filter. These filter classes are defined in the old EN779 standard, which is really more for ventilation systems. But EN779 was actually made obsolete in 2018 and replaced by a stricter and better standard ISO 16890. On the right, you can see this standard summarized in a table, with the old classes roughly mapped to the new ones based on experience values, not entirely official. ISO 16890 defines the classes EPM1, EPM 2.5, and EPM 10. This means that testing always starts at 0.3 microns and goes up to the upper bound defined by the class. So EPM1 is tested from 0.3 up to 1 micron. And this interval is the most relevant when comparing to EPA and HEPA, because it covers the most critical particle size range. Here, the M6 filter only achieves 10 to 40%. In the EPM 2.5 interval, 0.3 to 2.5 microns, it can sometimes reach 50%, which is enough to qualify for that class. But when you look at Ecovacs' own specifications, shown in the left-hand table, you'll notice they chose not to report those values. Instead, they highlighted EPM 10. And of course, that looks much better. 65 to 80%, as in Ecovacs' case, sounds nicer than 20 to 50%. The F9 filter does a little better, reaching 80 to 90% in the EPM1 band. But even this is still far from HEPA or EPA, because the testing is not done against the MPPS, most penetrating particle size, but rather across the broader 0.3 to 1 micron band. That makes it absolutely incomparable to EPA or HEPA filters. Overall, I find the way Ecovacs presents this to be really quite wild and, in my view, highly questionable. Finally, let's take a look at two manufacturers who at least dare to wave the HEPA flag. We'll examine closely whether they actually deserve to do so. First, we have Neato with the Neato D10. This model is advertised with HEPA-level filtration, or more precisely with the term true HEPA, which already raises some questions. When we look at the stated filtration performance, even more questions arise. It says up to 99.97% for particles down to 0.3 microns. But as we discussed earlier, if the filter were truly tested against the HEPA standard, this value wouldn't be up to, it would be the minimum performance required. In other words, 99.97% is not the best case scenario, but the lowest efficiency a filter must achieve to qualify as genuine HEPA. So, as with the D9 or D8, where the company claims E11 standard, it seems doubtful that this is entirely accurate. And indeed, if we look at the filter packaging, we notice a small asterisk next to the 99.97% claim. That asterisk clarifies that the figure comes from internal lab testing. Adding to the confusion is the use of true HEPA. This term actually has nothing to do with the official HEPA standard, it's just marketing language, as also noted by Vacuum Wars to claim real HEPA filtration. Lastly, let's take a look at Dyson. For the Dyson VisNav, Dyson states a filtration performance of 99.99% for particles as small as 0.1 microns. Please note the correct wording here, this is how it should be phrased. And this level corresponds to HEPA-grade filtration. Dyson also refers to an external testing institute and a test procedure called ASTM F3150. This is not a new test standard, but rather a testing framework that incorporates various already existing standards as points of reference. Among these are ISO 29463 and EN 1822. As is well known, these standards also involve testing against the MPPS, most penetrating particle size, which includes particle sizes down to 0.1 micron. Within this testing framework, there are two ways to achieve compliance. One option is a test focusing solely on the filter itself, which is ASTM F1977. Based on Dyson's marketing materials and how they present the information, I would argue that Dyson likely chose the ASTM F2608 path. That method evaluates the entire device's filtration performance. In other words, it examines whether the vacuum cleaner contaminates the room air during use. For this, a test room is set up with a carpet deliberately contaminated with dust, specifically Arizona test dust A2. This dust is significantly finer than the test dust I use. It even contains particles smaller than 0.1 micron, whereas my test dust has a minimum particle size of about 20 micron, which is much larger but makes more sense for my test methods. During the ASTM F2608 procedure, the vacuum is operated on the carpet, and it is measured whether dust is re-released into the air. This means it's not just about the filter, but also the seals and the overall containment of the device. The specification whole machine HEPA filtration system suggests that Dyson has chosen the F2608 procedure for certification. Overall, Dyson is also the only manufacturer whose claims in this area are traceable to such an extent. That said, there are still issues with the disclosure of certificate numbers or test report references, which would make it possible to cross-check directly with SGS, the testing institute. In my own research for this video, I was unable to do that. This is something I plan to follow up on directly with Dyson as well as with other manufacturers by sending them an inquiry to ask about their testing, their references, and exactly how the process was carried out. So, we also need to talk a bit about the methodology and the conclusions drawn. The problem here is that such filters are designed for specific volume flows and pressures. And in the Vacuum Wars test, we can see that the filter was connected directly to the fog machine. This most likely means that the conditions no longer correspond to those inside the robot. There is the possibility that the volume flow was too high or the pressure was too high. In such cases, the filter may no longer be able to achieve the filtration performance it is rated for in the specifications. I wouldn't go so far as to say that any filter would have passed this test. But there is this big question mark surrounding it. And then there's the further issue that the conclusion is drawn. Just because the original filter was able to filter particles of 1 to 5 micron, it must therefore meet the HEPA standard and must therefore be a HEPA filter. As we have already seen, that is not the case anyway. But even beyond that, such a conclusion is not valid. All you can really say is that for that particle size range, one filter performed better than another. A better approach can be seen in the tests from ratings. They use a fog machine that can generate particles in the 0.2–0.3 micron range. They also have a better setup. They let the vacuum robot itself suck in the fog, and then they measure what comes out at the other end. Unfortunately, they only do this visually. That is also a problem because small concentrations of particles in this size range simply cannot be reliably detected by eye. For that, you really need to use a particle counter, ideally in a sealed test chamber, just as is done with air filters in the ratings tests. And you can clearly see in those ratings tests what a difference this makes in terms of HEPA filtration performance. For example, Roborock filters generally fail in almost all cases, with visible smoke leakage. The rating setup also has the added advantage that it makes it possible to detect leaks in the entire system. In conclusion, it should be noted once again that the whole topic is very non-transparent for the user and quite difficult to understand. You basically have to rely on the manufacturer's information, and in most cases you'll hardly ever find certifications by third-party organizations, at least not in the area of robot vacuums, and certainly not in the official specifications. And regarding third-party filters, I personally stopped buying such products. That doesn't even necessarily have to do with the filter material itself, but rather with the fact that the gluing and sealing are often very poor. In some cases, the filter material is simply placed into the filter frame, which is, of course, absolute nonsense. There's also a big difference between EPA and HEPA certification regarding additional required testing. If anyone is interested in learning more about that, let me know in the comments, and I might make another video on the topic. So, that's basically it for this topic. If you'd like to support me, I have a Ko-fi link that should pop up somewhere here or can also be found in the description. It's something similar to Patreon, where you can support me financially if you'd like. Otherwise, feel free to like and subscribe. That always helps and of course doesn't cost a thing. Thanks again for your support. Until then, see you next time. Bye.